we are here to talk about the AWS Data Protection Services and how AWS innovates and automates and makes it easy for customers like yourself. The way we break out our customers are, there are customers that are in their journey to migrate to AWS, and then there are other customers that have migrated to AWS, but still need to understand the overall aspect of how do all of these data protection services play a part in them meeting their compliance or security regulations. Right, so my name is Ritesh Desai. I'm the general manager for one of the AWS data protection services, AWS Secrets Manager. And with me, I have Zach Miller. Zach is a senior security specialist. He has experience working with multiple customers like yourselves and helping them through their journey to securely move their workloads and specifically their data to the cloud. All right, so what's the most valuable asset for us? The most valuable asset is data nowadays, obviously. Customers like yourself, trust AWS to make sure that we secure their most sensitive data, right? And AWS provides a comprehensive set of AWS services that help customers or enable customers to securely manage their own keys, their certificates, application secrets. What say you? What we'll do as part of this presentation is walk through a sample workload and then essentially see how these services like AWS Key Management Service, KMS, I'm sure you've heard about it, AWS Private CA, the Private Certificate Authority, and AWS Secrets Manager sort of play a role in making sure that you as a customer across the board meet your expected organizational guidelines. The agenda, as you see on the screen here, it specifically starts with data, right? The first thing customers want to do is obviously move data securely over. So that means it goes from one place to the other, and when it's in transit, it needs to be secure. So that's why we start off with data in transit. The aspect about once data is in transit, it needs to be stored somewhere. In a database, in a file system like S3, and at that point of time when the data is at rest, it also needs to be secure. That's one second aspect of it. But just having data in there, obviously, as you know, doesn't make anything work. So applications have to interact with that data. To make sure that when applications access that data, the applications are secured, authorized, authenticated even, to ensure that they are who they say they are, and they have the access to access that data and take any action. So that's the last part of it. And second to that is, once you have all of these, if you want to call them Lego blocks in play, how do you make sure that we prove, especially to auditors and other places, that you have a centralized security model that can be proven that it meets those guidelines? So we'll talk a little bit about lifecycle management as well. And obviously, we'll finalize with Zach talking through the overall workflow of your journey of data through the system. We talk to customers across the world, and one of the things that becomes really hard for them is to adhere to this ever-changing, ever-evolving privacy regulations across regions. Right? And the three top things that come up are, what are the data storage and data processing services available in AWS? The second one is, how does AWS itself, for our own sake, think about privacy in the cloud or security compliance in the cloud? And the third thing is, what data services does AWS provide, or data services does AWS provide to help customers meet those expectations? So that's where AWS can help. We have experts that have nuanced understanding of these region-specific guidelines and specific security expectations from a specific region, and can help make it easy for customers to comply with these expectations. So as you might have heard in other presentations, our objective is always to work backwards from the customer, and we strive to invent and deliver on your behalf. Right? In the case that in this specific case, we strive to provide infrastructure, services, any customer education information to make sure that these services meet your data protection guidelines, your expectations, and consequently simplify your journey. I'll talk a little bit in detail about the top 4 protection use cases. So data in transit, and you obviously know what that means, but just as understanding, as it moves from one place to another, in this case we talk about networks, but it could be from an application to another application, because some action has to be taken based off of their data. AWS provides services, and Zach will talk a little bit about them in the next few slides, like AWS Certificate Manager or AWS Private Certificate Authority, that ensure that the data is transferred and is encrypted using TLS, right? And transport layer security, I'm sure you're all aware of it since you're here. TLS ensures that when that data is transferred, both applications that interact with that data are who they claim to be, and the data, when it's transferred from one place to another, maintains its integrity, like it's not forged or it's not tampered with. The second part of it is interesting, because there are customers that want to store them in file systems, store the data in file systems. Some that want to store in database like RDS. Just want to make a statement clear. Every data element that is stored in AWS is encrypted by default. Now, if customers want to add more protection and more control, there are aspects that we'll talk about how you can do that within S3 or within RDS using either KMS or Cloud HSM. And now, I talked about it a little bit, but secrets enable access to this data. These secrets are how your applications authenticate and authorize to be able to take action. These secrets need to be, or at least that's our best, that's our advice, or that's our guidance to our customers, is to separate data from your secrets. And that helps you manage data independently of your secrets. So there is an aspect of managing secrets, or the lifecycle management of those secrets or credentials. We'll talk more about it specifically in terms of a service called AWS Secrets Manager. And talk more as well after the session, because I'm excited to talk about it. But AWS has these purpose-built AWS services that then enable customers to manage the lifecycle of data and all secrets independently. The intent there is we want you to obviously focus on the best thing for your customers. And we want you to be able to delegate all of that responsibility and trust AWS to do the right thing in terms of security. But obviously, there is a way, like I said, at the end to make sure you can prove the overall data security model. The ultimate decision or ultimate goal for us is to minimize and hopefully, as a North Star, eliminate human decision making in this process. And that's what we are striving for in all of these services that you'll hear later in the slides. Now, this is the big journey. This is data flowing from outside into AWS, within AWS, and then applications interacting with that data to take some action, essentially do some use case or do a business case for you. And then finally, as you see, there's an aspect called AWS management and governance. Those are the services that help you essentially prove that you've set up right access permissions, right secret lifecycle management setups, right strength in your password, right certificates, all of that in this overall journey. So now let's start from the left. And I'm going to pass the baton on to my partner in crime, Zach, and he'll walk us through the next 2 parts. Zach.
Thanks, Ritesh. So let's start by diving a little bit deeper into data in transit encryption, which Ritesh mentioned earlier. If you look at this data protection journey slide, we'll kind of go bit by bit, like Ritesh mentioned. And when we talk to customers like you about moving their data into AWS and beginning that cloud migration journey, one of the first questions we get is, how do we move our data at AWS securely? And there's kind of 2 answers to this, right? One is client-side encryption to encrypt the data that's coming in. This is obviously, there are certain situations where this is very useful, but there are some significant disadvantages there, as it makes kind of manipulating or processing the data difficult without first decrypting it with that original key. So the more commonly used approach is encrypting data in transit using transport layer security or TLS, like Ritesh mentioned. And so what do you need for TLS? You need certificates. Issuing certificates allows you to encrypt data in transit with TLS or identify and authenticate endpoints. So you can use it for things like certificate-based authentication, for example. And in short, a certificate is a public and a private key, and some information about the organization that owns the certificate. Of course, customers can choose to manage their own certificates, but as someone who's been a system administrator in the past, in charge of kind of manually issuing, rotating, installing certificates, it's not fun. And in fact, I remember back then, mistyping a domain name and breaking the SSL stack, causing an outage, telling myself, I'm never ever going to work with certificates again. And now it's something I talk about every day with customers. But the nice thing here is that AWS makes it easy to issue and manage certificates, which leaves you free to focus on more important tasks. And so to do that, we have two primary services that I'll talk a little bit more about. Ritesh mentioned them earlier. One is called AWS Certificate Manager, or ACM. And the other is AWS Private Certificate Authority, or AWS Private CA. And many of you probably know this already, but just to get everyone on the same page, public certificates are trusted by default on all major operating systems and browsers. Private certificates are only trusted by your organization, and often they're used for internal applications, use cases where publicly trusted certs aren't really necessary. So ACM, they're the first one, allows you or enables you to provision, manage, deploy both public and private TLS certificates, but it is pretty specific to those TLS certificates. AWS Private CA is a highly available CA service that you can use to create, manage certificate authorities, and issue private certificates for use with TLS, of course, but also things like code signing, email encryption, certificate-based authentication that I mentioned earlier. So these certificates are highly customizable, but they're not necessarily publicly trusted certificates like the ones you would issue directly from ACM. So let's dive a little bit deeper into ACM itself. ACM works by integrating with AWS services like Elastic Load Balancing to issue and provision certificates to your resources, allowing you to reduce your operational overhead required to install those certificates. So you're able to kind of just use the AWS Management Console or our APIs to issue a certificate from ACM, and then you can use that same Management Console or the APIs to, for example, bind that certificate to a load balancer. So you don't need to worry about installing the keys in a trust store and dealing with all those kind of manual operations that come along with dealing with certificates. You can simply pick from a drop-down in the Management Console with a few clicks to say, I want to bind this certificate to this load balancer, for example. And ACM will also handle the renewal of these certificates, automatically issuing a new certificate, binding it to that same associated resource when the certificate is about to expire. We do recommend using domain validation because it requires no manual action on your part for managed renewals. But ACM does also support email validation as well. Like I mentioned previously, instead of manually requesting, installing, and rotating these certificates with ACM, you can simply request the certs using the console and the APIs, select the AWS resource you want to bind the certificate to, and AWS handles the rest. I mentioned, the integration with different services, so that list on the previous page is not necessarily comprehensive. There are a lot of services ACM integrates with. But I keep using the example of Elastic Load Balancing because that's a common one for customers. And so ACM works by integrating with these services to provision and manage TLS certificates, but you can public certificates. But you can also use ACM to manage and renew private certificates that you issue from your CAs in AWS Private CA. So if you look on this diagram there on the left-hand side, you can see that not only can you again kind of issue these public certificates from us, but you can also use those private CAs you create to issue private certificates as well with ACM. And the benefit that gives you is having those integrations with services. Again, you can simply choose a load balancer or choose CloudFront distribution to assign those certificates to. Another important thing I'd call out is in terms of monitoring the usage of your certificates. Amazon CloudWatch and Amazon EventBridge, of course AWS CloudTrail are all integrated with ACM so that you're able to view all activity against those certificates, see API calls to ACM and Private CA. Okay, so I talked a little bit about Private CA already, but let's go a little bit deeper into kind of how that works. AWS Private CA allows you to create and manage private certificate authority hierarchies and issue private certificates. These certificates are highly customizable. You can use them for many use cases, like I mentioned, from TLS to code signing. The private keys for these CA certificates are stored in FIPS 140-2 Level 3 validated HSMs. And with AWS Private CA, you can keep your CA private keys secure without needing to purchase, install, and manage HSMs, which are kind of notoriously expensive and difficult to maintain without the right expertise. That's something I've done in my past as well, and again, I can kind of vouch that AWS Private CA makes it a lot easier to manage that PKI. Private CA also supports both certificate revocation lists, or CRLs, as well as fully managed online certificate status protocol, or OCSP responders for revocation. I kind of talked about this a little bit when we talked about ACM, but you can use both the ACM console and management, or the management console and APIs, or the AWS Private CA APIs, or the CLI, to request certificates. Private TLS certificates can be managed by ACM for that easy integration for services like Amazon CloudFront and those managed renewals. Private certs issued from your private certificate authorities can also be used to encrypt data, sign code, identify and authenticate resources from your workloads, both inside and outside AWS. So, containerized workloads running on Amazon Elastic Kubernetes Service, or EKS, but also even, on-prem web servers that you have. You can use Private CA to issue certificates for use in those applications. I mentioned a CA hierarchy. I expect a lot of you may know what that is, but just to kind of, again, level set, CA hierarchies are used to create a chain of trust. So you have that root CA at the top there. It acts as that root of trust. And the root CA signs the subordinate CAs below it, indicating that these CAs are trusted by your organization, and the certificates it issues are also trusted by your organization. Typically customers will use the 3-tier hierarchy like you see on this slide, with a root CA, an intermediate CA, and then an issuing CA. But that's not necessarily required. You can have a 2-tier, 3-tier, 4-tier. Kind of depends on your needs, but I would say 3-tier is the most common that I see. The benefit of using a CA hierarchy like this, there's a few, but you can kind of effectively differentiate between different business units in your org that might have different requirements around certificates. But if you also need to replace an issuing CA, for example, maybe you're creating a new CA and just adding it in, you can simply add that new CA. As long as it's signed and in that same chain of trust, it's going to be trusted by your organization because it chains up to that same root CA. One cost optimization I want to call out that not all customers are aware of is this cross-account CA sharing with a service called AWS Resource Access Manager, or RAM. Ritesh mentioned AWS is a customer-obsessed company. So we'll often hear feedback from customers that creating a 3-tier CA hierarchy in all their accounts quickly becomes cost prohibitive, it's difficult to manage. So we want to make sure customers are aware that you can share these CAs created in AWS Private CA across your AWS accounts, or even across your entire AWS organization, which can greatly reduce your cost, right? Because you only need to create one CA hierarchy and share it across all your other accounts, as opposed to creating a 3-tier or more in every single account. Because you can imagine how those costs might add up if you have 50, 100, or thousands of accounts like some of our larger customers have. And now I'm very excited to be able to announce a new feature that's coming soon, the AWS Private CA Connector for Active Directory. So you'll soon be able to use certificate authorities created in AWS Private CA to issue certificates to domain joined devices. You can replace on-premise Windows CAs with CAs in Private CA without needing to manage hardware security modules or invest in public key infrastructure on-prem. You can automatically deploy certificates to domain joined devices using the same auto-enrollment and group policy-based mechanisms your administrators already use. So it kind of helps you reduce that PKI complexity, because you no longer are dependent on these on-premise HSMs that might be kind of locking you into your data center. You can reduce upfront PKI investment and those ongoing maintenance costs, because again, you don't need to worry about managing HSMs and managing the infrastructure that goes along with running a PKI. And again, you will be able to use those same kind of mechanisms like auto-enrollment that you're already used to doing. So I think that's really fantastic, and I think it's going to help customers reduce costs and reduce their complexity. And so that will be coming soon. Okay, so I covered a lot there, but let's dive deeper into data at rest encryption, which is the second use case Ritesh talked about. Again, if we look at this data protection journey slide, maybe the second question customers might ask after they get that data into AWS securely is, how do we keep this data on AWS confidential, right? How do we protect our data at rest? And primarily we see customers use server-side encryption to encrypt that data at rest. And to do server-side encryption, or encryption in general, of course you need encryption keys. So it's important to talk about key management. And so there's really a few options for key management on AWS that I'll talk about here. You may be already familiar with AWS Key Management Service or AWS KMS and AWS Cloud HSM. AWS KMS is a highly managed, cost-effective service that helps you manage those encryption keys on AWS. I think the beauty of KMS is that, again, you no longer need to worry about managing those hardware security modules. You'll see that as kind of a theme throughout the presentation already. You don't need to worry about these kind of complex, expensive, difficult to maintain infrastructure like an HSM, because with KMS, you really only need to think about keys. You create keys, you can manage those keys, the access policies on them to make sure only the appropriate parties are able to use them for encryption and decryption. And you can simply use our APIs or the management console to, again, very easily kind of assign a key to say, for Amazon Simple Storage Service or S3, you might say, I want to just say this KMS key is going to be used to encrypt this bucket. You can do that with a few clicks in the AWS management console or an API call, right? As opposed to needing to understand and manage these HSMs or use some kind of like arcane library like PKCS11. So I think customers like that you have this easy solution to go ahead and manage those encryption keys that you use for encryption on various AWS services. But again, customer-obsessed company, we have customers that do want a little bit more control over their encryption keys. So AWS Cloud HSM provides an option for this single tenant HSM in AWS that's in your complete control as a customer. AWS helps reduce your operational overhead by handling things like purchasing and installing the physical HSM hardware. We manage things like backups, but nearly everything else is managed by you, the customer. So meaning you have a lot more control over things like your key generation patterns, the cryptographic algorithms you use, but you also have a lot more responsibility because you must, got to plan for your throughput and availability needs and how to manage access to that Cloud HSM cluster. So, customers like you wanted to take advantage of those benefits I mentioned of AWS KMS, like integration with over 120 AWS services, while still having kind of the same level of control that Cloud HSM provides. So we built Custom Key Store, which is a way to store your KMS key material in your Cloud HSM cluster. So that means you can use those KMS APIs and those service integrations to manage your encryption keys while also keeping that key material in a Cloud HSM cluster that is actually specific to you as the customer. And then lastly, we released KMS External Key Store, or XKS, at reInvent last year, which is similar to Custom Key Store, but instead of storing your encryption keys in that Cloud HSM cluster, you can actually keep them outside of AWS entirely. And so you can keep that in a key management service or a key manager in your data center, for instance. And I'll talk about that a little bit more in future slides. But first, let's start talking about KMS in general. So KMS works, again, by integrating with over 120 AWS services to allow you to use these keys to encrypt your data. But it also has other functionality like the ability to sign and verify data or generate and export those data keys which are used to encrypt your data in AWS services like Amazon S3. You can also generate and verify message authentication codes using HMAC. And again, similar to ACM and AWS Private CA, AWS KMS is, of course, integrated with Amazon CloudWatch, AWS CloudTrail, so you can see the activity on your keys and understand how they're being used, monitor, and set up alarms for certain things you may want to be notified about. So let's look at where you can keep your key material in KMS. I talked about a few of these options already, but I think kind of the default way, which is recommended for most workloads, is to simply generate and store your key material in AWS KMS. The KMS HSMs are validated at FIPS 140-2 Level 3 to provide a highly available, highly durable place to store and manage those encryption keys. But again, customers wanted even more control over their encryption keys, or maybe they have requirements for a single tenant solution, so we built Custom Key Store, which enables you to store your key material used by KMS in that Cloud HSM cluster that you control, like I mentioned earlier. Some customers, again, wanted more control over key generation patterns, but didn't necessarily want to utilize Cloud HSM. So we built the capability to import that key material that you create on-premise into AWS KMS. And so again, like if you need that control over key generation patterns, or you want to be able to prove to your auditors, like I generated this key, you can use that and then import that key into KMS to take advantage of all the benefits KMS provides. And then lastly, customers with requirements around, say, digital sovereignty, wanted to be able to store those keys entirely outside AWS, while again taking advantage of those benefits that AWS KMS provides. So we built that too. XKS allows customers like you to store your encryption keys in an external key manager entirely outside of AWS. But I will say you should definitely consider your requirements carefully. This means you're now in full control of the durability and availability of that key. If the key manager that you have, say, in your data center, and that stores that key becomes available to KMS, or unavailable, sorry, to KMS, maybe you have, there's a power outage or a device failure or something, we won't be able to use that key for encryption and decryption. We don't, import a copy of that key to AWS. It is solely there in your, external key manager. And so if that becomes unavailable, we're not going to be able to use that key. So, you definitely want to think carefully about this. There's also things like, the physical distance between you and the nearest AWS data center. AWS has a lot of really smart folks, but we haven't been able to figure out how to change the speed of light. So you still have this kind of, physics that means you may have degraded performance compared to, just using AWS KMS natively without XKS, simply because you may be, physically separated from the closest data center, which of course is going to increase that, round trip time. So again, very cool feature that a lot of customers are really interested in, but I just would definitely encourage you to consider those requirements carefully and understand the trade-offs when you want to use this feature. So I mentioned data keys, I mentioned integration with different services, but one thing customers don't always understand is that, there is this concept of envelope encryption. Probably a lot of you are familiar with it, but in short, it's essentially that services are going to use AWS KMS to create data keys. Those data keys are used to encrypt the data. And then, there's this KMS key at the top level there on the diagram on the right-hand side that is going to actually, protect that data key. So you generate these data keys, they encrypt the actual data, and then those data keys are encrypted or protected with an AWS KMS key. So one thing I want to call out, though, is that different AWS services use these data keys differently. So, the number of data keys used by the service can vary greatly. We have one data key per Amazon EBS volume. Similarly, you have one data key per Amazon RDS instance, because again, you're just encrypting that EBS volume that underlies the instance. But for AWS Lambda, for example, you may have tens or dozens of data keys, or even hundreds of keys, depending on maybe your encrypting environment variables. You have many of them. If you look at AWS Secrets Manager, which Ritesh will talk about here shortly, you may have thousands of data keys. And then even on that next level of magnitude, you have billions of data keys potentially with Amazon S3, because you may have billions of objects, and at least in the traditional model, you have one data key per object, which is why I want to also talk about another cost optimization, which is S3 bucket keys. Historically, every object in S3 has this single data key that was provided by AWS KMS that's used to encrypt every single object, one-to-one relationship between data key and the S3 object. But that can impact performance and generate potentially high costs if you have billions of objects and you're constantly calling KMS to decrypt data keys, encrypt data keys, and use those KMS keys to protect the data keys themselves. So we built S3 bucket keys, which is kind of this intermediate key, and S3 requests the bucket keys from AWS KMS and uses that key to derive data keys. And so, it doesn't need to continuously call KMS because we keep that data key or that bucket key for a short period of time. And so you're, again, no longer needing to consistently and constantly call AWS KMS to do the decryption of those data keys. And obviously your results will vary, but at scale, we've seen customers save up to 99% on their S3 encryption costs with KMS. So that's pretty huge. Another really exciting thing I want to talk about is something we just launched in preview, which is the AWS Database Encryption SDK. It is a client-side encryption library that focuses on databases. Right now it's compatible with Amazon DynamoDB, but our vision is to kind of bring this to all the AWS database services. And a few highlights I'll talk about is it does do attribute level encryption, and it supports searchable encryption. So typically you would need to decrypt the entire table in order to search through the data within it. But with this, you can actually just search that data without needing to actually encrypt that entire table, which is fantastic because it improves performance, right? The other thing that's important to call out is it's built with multi-tenancy in mind. So, say you're a SaaS provider or you have a lot of customers and those customers tell you, I have a requirement to, my data should only be encrypted with my keys. This library this SDK is built for that, right? So you can actually have a separate KMS key for each of these kind of attributes, and then that allows you to have separate access controls on those encryption keys. And again, kind of built with this multi-tenant model in mind, which I think is going to be really helpful for customers that have those requirements again from their customers that say, sure, all this data may be in a single database, but I want my data encrypted with a key that's specific to me. And one other thing I'll talk about is, I'd call out here is there's a seamless schema change, so you really don't need to change your database schema in order to use this, which I think is really useful. And one other thing I'll say too, before I move on, is that, again, this isn't developer preview, so we don't necessarily recommend using it in production yet until it becomes generally available. But we do really encourage you to try this out, test it. Please provide us feedback on what you see and what you'd like to see in the future in this SDK so that we can continue to improve it before it becomes generally available. Another very exciting launch that just happened this week, which is very cool, is AWS Payment Cryptography. So if you're familiar with the payments industry, many customers have these on-premise hardware security modules that are specific to payments. And what we've found is customers would say, I want to move my application to the cloud, but I'm kind of locked into my physical data center because, I can't do some of these payment cryptography operations without this, again, on-premise HSM in my data center. And so, I want to move these applications to the cloud, but I'm kind of stuck here because of, the dependency on these on-prem payment HSMs. So we built AWS Payment Cryptography, which is this elastic payment cryptography service. It allows you to perform cryptographic operations required for card payments in a compliant manner, reduces that operational burden by using a fully managed service built to meet PCI standards. And it can easily integrate with card payment applications using AWS native APIs. Because this service can be a little bit similar to AWS KMS in the sense that you don't need to worry about managing that HSM infrastructure. I said that was going to be a theme. You only need to worry about keys. You create those keys using the CLI or APIs, and then you can use our APIs to say, decrypt this pin block for me. I'll provide you the key and the format and some other information, and it'll go ahead and actually do that for you without needing to manage, again, these kind of arcane hardware devices that require some expertise to maintain. And so you can implement key exchange, generation, and storage in accordance with PCI standards. And I think if you're familiar with things like derived unique key per transaction or duckput, this service might be for you. Some of the benefits of using AWS Payment Cryptography, again, you reduce that dependency on dedicated payment HSMs while achieving your cloud migration goals. Reduce that operational burden because you're using this fully managed service. Don't need to worry about managing those HSMs. You can harness high throughput and low latency. If you're familiar with the payment industry, it's very spiky, and there are certain times, think about like Black Friday or something in the US, where a ton of people are buying a lot of things, and you need that capability to scale with the needs of your business. So I think this is also fantastic. This is a very highly scalable, elastic service. You don't need to kind of over-provision like you traditionally would with an on-prem HSM. This service will actually scale to meet your needs. And of course, you simplify setup with no need to provision those hardware instances. You can simply create the keys and start using them. You don't need to worry about, again, kind of managing those HSMs either on-prem or in the cloud because it's purely based on APIs and keys. Okay, and so with that, I will pass back to Ritesh, and he's going to talk about securing application credentials.
All right, thank you, Zach. That's a lot of HSM work there. But I think the overall theme, though it was HSM, there was a theme around management of these aspects that required you to secure your data in transit and at rest, and then addressing specific use cases like AWS Payment Cryptography, which is pretty cool. So I'm sure you all know, but I'm just still going to ask the question, what are application credentials? And I talked a little bit earlier in the slide about the ability for an application to authenticate and be authorized to access some data to take an action, right? Simply put. And we need to have an ability to first secure them and then have the ability to manage these credentials or that life cycle itself. The data lifecycle is separate from this lifecycle. We saw earlier the customers do build their own custom setups. At times even store, maybe not as much nowadays, but in config files and other places. And I just had a meeting where we talked about it as well. So that's where AWS Secrets Manager comes in. But before I jump into that, I want to just reassess where we are at in our data journey. So we moved our data into the cloud. We are making sure it's moved in transit, encrypted through services like Certificate Manager, PCA, and obviously within AWS Cloud as well. And then we have the ability to use a key and manage that key in services like Cloud HSM or KMS to encrypt it at rest. Now, how do you share this securely? So that's where we'll go. This specific thing you have always heard about, IAM or AWS Identity and Access Management. That is what is built around all of these services to be able to secure or authorize or strictly control access to these secrets or to the data. All right, so I am personally also biased, but also excited about this, to talk about this service. One of the key part of this about AWS Secrets Manager is it goes beyond use cases. It is not specific to a specific or type of secret. For example, as you heard about ACM, Certificate Manager, KMS, Key Management, ASM or AWS Secrets Manager moves beyond that. It enables customers to manage the lifecycle of any arbitrary secret. Maybe a database password, auth token, API keys. We even see customers use it for certificate private keys. So this whole big cycle, or this aspects of features, I just want to reassess and go back to something you said. Secrets Manager, anything you store in Secrets Manager is secured by default. And the way it's secured is using KMS. But you don't have to use a CMK or a customer managed key, which you have to pay for. Because AWS manages securing that secret with what we call AWS managed key, which means it will always be secure. Now, for customers that want control over the key that encrypts the specific secrets, they can also use or create a customer managed key in KMS that then secures their secret. That part of it was the secure storage part. I mentioned IAM before, and the fine-grained access control, the ability to strictly manage who accesses secrets is done through IAM. Right? You can have role-based policies, you can have resource-based policies, and control access to the secrets. That then access your sensitive data. So I'd be really careful about that. The automatic rotation part is what we continue to innovate on. Right? When we launched the service, we had native integrations to automate rotation for Amazon database services like RDS, DocumentDB, Redshift. We have now also shared AWS Lambda functions through open source, where customers can customize them to rotate secrets for third-party applications or other AWS services. And following the theme of KMS, we are going forward and natively integrating with more and more AWS services, where the essential automatic or the rotation part of your secret becomes seamless, where you don't have to run a Lambda function in your accounts. It just happens, and it rotates at the schedule that you mentioned. The retrieval part, of course, we scale, and to the last point about the ability to scale, we scale for retrieval, secure retrieval, to about 10,000 TPS, and obviously the data is transferred over in transit encrypted. The last part of it is we do integrate with many maintenance and governance services, or AWS Secrets Manager does, to be able to use them to have a provable or audit mechanism for you using CloudTrail, and then CloudWatch alarms on top of CloudTrail, or an AWS Event Bridge that essentially grabs a deviation from your expectations and then sends a note out through Amazon SNS or as a SMS push or email. Replication is an interesting one. We launched it about a year and a half, 2 years ago. There are customers, and I'm sure you all probably fit into that have a business continuity plan, or a disaster recovery plan, if you want to call it that, where you have multiple regions set up for your failover. let's take RDS for example. You fail over from primary region A to primary region B. What Secrets Manager enables you to do is now replicate these secrets to those regions as well. Let's say you have a secret that accesses or admin secret that accesses the RDS database, and they will always continue to be in sync. So when you fail over your database, the secret is there to be able to use by your application. Essentially, that means the availability risk is minimized or eliminated. Talked all of that in the past slide, but it's sort of like a pictorial representation of everything that I mentioned there. Where I want to focus on, or where Secrets Manager is focusing on, is to eliminate that Lambda section, the orange section that you do. The more and more we integrate with more services with AWS, we will have more managed rotation, and that's where we want to go. And that's what I want to talk to you about. And that's why rotation is a separate slide. And you will ask me why there is a separate slide for rotation. It is important. We initially, when Secrets Manager launched, there were a lot of customers that just used it for secure storage and retrieval. But it ended up being, and I'm sure in audits and other places you identified it, it becomes a risk because if it's a long-term secret, it could have been looked at, it could have been accessed by multiple people. You need to rotate it. And I'm sure you have tickets and whatever mechanism you use to identify those. So the ability to rotate the secret is important, and we understand it, and we are working towards making it essentially seamless for you to rotate your secrets if you store them in Secrets Manager. AWS Lambda is not a bad way to do it, and customers today do it. It does require a little bit of customer heavy lifting, which means you have to have that Lambda. It needs to run in your account. It needs to be monitored and managed along with your secrets. Right. So I'll talk a little bit about that as well. Customers have been asking for more flexibility in rotation. What that means is usually when we set up a rotation, let's say it's a 30-day rotation, AWS Secrets Manager would make a decision when to rotate that secret on the 30th day or 31st day, depending on the peak hours and whatnot. What customers wanted to do is have the ability to set up a time frame when the the secret gets rotated, especially like during your maintenance windows or things like that. So we launched something in the last year where customers can say, okay, on this day between 9 to 10 p.m., rotate my secrets. And we can address that or do that as well. There are a lot of other configurations. I mean, you can use all sorts of things to set up your rotations, multiple configurations. The other thing that was noticeable is I mentioned OAuth tokens and API keys as some things that customers store. And the fact of the matter there is that these need to be rotated more frequently than a day. Sometimes 10 minutes, sometimes 5 minutes, which Secrets Manager did not support until last year or 6 months ago. Now we can automatically rotate secrets every 4 hours. And we continually address it, and we'll probably get it down to less than a minute. This is what I wanted to share. Is a very recent launch, happened in December last year. We've always integrated with RDS to manage their secrets in Secrets Manager. What this does is essentially it removes the part about where a customer need to go from an RDS instance launch to now Secrets Manager launch to create the secret. It all flows in a single place. So it's natively integrated where as customers are doing their main job of setting up their EC2 instance, or in this case RDS instance, you can set up your secret in Secrets Manager. And then with a checkbox, set up rotation. So RDS and Secrets Manager, internally between them, rotate your secrets on whatever schedule you decide. But it also gives you the flexibility to go to Secrets Manager and set up rotation on a different schedule if you need to. So both work. So this is what customers have been asking for. If you want to talk more about it, I have time after the session. But the intent there is that we continue to work backwards from what we hear from customers, and we'll build more such integrations in the near future, especially for database services. So lifecycle management of those, and what we end up calling provable security. So there are few places that we can help customers with. There are things like AWS Well Architect guidance that helps you say, okay, which are the services that we can use to essentially say, oh, all these security parameters have been checked, and these are the services that you can integrate into your overall solution to prove that. And there are other places like talking to the teams that are involved that can give you that information. We also share customer education blogs to help move the thing forward. But we also have teams that come in and talk to customers as needed to make sure you understand what the scope of the expectations of that organizational guideline is and how we can prove it through AWS services. So that's where provable data protection comes in. The three I would want to talk about, and especially AWS Config, but it wasn't mentioned in the earlier slides. I'll talk about Secrets Manager, but it happens also in KMS and other services. We support or provide managed rules, right? So in this case, the one example that you see on the slide is about if a secret is unused, you want to know. You want to probably delete it so that you don't end up paying for it. That's one thing. There's also one that talks about, hey, secret's not rotated in X number of days. So you want to know that because it actually deviates from your organizational policy. So AWS Config has specific managed rules. I think AWS Secrets Manager supports about 5, but customers can customize and create their own rules and run them across all accounts if required in a region, across regions, to say where on the scope of your organizational boundaries of security do they deviate from your plans. Zach mentioned CloudTrail, and every activity, everything that happens on a secret or a key or a certificate gets logged in CloudTrail. So you will have the ability to go access that. Now, there are billions of logs happen every day. So assuming you're not grepping through that, there's a way to put alarms on specific actions. Like, let's say, rotation failed, that you want to be intimated about or you want to know about quickly, so you can take action. You want to know if a key had access denied, things like that. So that's where CloudWatch alarms and things like AWS Event Bridge can help trigger an alert that share any such deviations from the policy. So the ability to kind of set up, so we did set up our data protected at rest in transit. We have application secured credentials that access these secrets. But there's an aspect where you are now setting up these permission boundaries with IAM role-based policies. There are also tools available where you can set them up in your CI/CD pipeline, like IAM Access Analyzer, Advisor, Trusted Advisor, which will help you understand if there are any changes or any unexpected accesses, like a public S3 bucket, for example. So there are things that you can do. That one is not on this slide, but that's more of a developer tool or a security admin tool that can be used as well. All right, so I'm going to send it back to Zach to put it all together for you.
Okay, thanks, Ritesh. So, this is kind of just a sample workload you see on the screen. Of course, it's a little bit simple. It's nothing too fancy. I just want to kind of illustrate how you can use these various services we've talked about to complement each other and have them work together within a single application. Sometimes customers, especially customers that are newer to AWS, want to understand, okay, there's all these different services that provide data protection, provide certificates, provide keys. How do I use them together? How can they complement each other in my workloads? So, if you look at this diagram on the screen, we have on the left-hand side, you have like incoming requests that are coming through an application load balancer, an ALB. Maybe that Amazon EC2 server you see there on the bottom is perhaps an application server, and maybe an Amazon RDS instance is used to keep customer data, right? Potentially sensitive customer data. So if we look at that green box there in the top left, number one, we have AWS Private CA, which issues a private certificate for TLS. And if you use ACM to request that certificate, again, you can use the AWS Management Console or the APIs to simply associate that certificate with a resource like this application load balancer, and it will bind it to that resource on your behalf. No you don't need to worry about moving the private keys onto that device, or kind of doing the normal things that would come with manually installing the certificate. You can simply pick from a drop-down in the AWS Management Console, or use our APIs to bind it to that resource. And then, of course, when that certificate is going to expire, ACM is able to actually handle that managed renewal for you, renew the certificate by creating issuing a new certificate and just associating it or binding it with that same resource. And then you look at the number 3, AWS KMS is going to provide the keys to encrypt those EBS volumes, for example, on this EC2 and the RDS instances. So I mentioned before, EBS uses one data key to protect that EBS volume, and that data key is protected by a KMS key at the top level. And so you can, of course, use key policy and IAM policy to protect access to those keys, and make sure that only the intended users of that key are able to use it for encryption and decryption. But in this case, we just have this Amazon EC2 instance and the data in the Amazon RDS instance being protected by that KMS key. But you'll also note that, like Ritesh mentioned earlier, KMS can also be used, or is also used, to protect secrets and Secrets Manager. So you also have, those KMS keys could be the same key or could be a different key, protecting those secrets as well. But how do we use those secrets? Secrets Manager in this case, in our sample workload, is going to be used to securely store and manage those credentials used for the RDS database, right? So you have local users on the database, and you can store the credentials for those users in AWS Secrets Manager. And then, for example, when a request comes through that ALB, it's sent to the Amazon EC2 instance, say this application server in our example, and that application server needs to grab some data, right? Potentially some sensitive customer data. So that application running on EC2 is able to make an API call, for example, to AWS Secrets Manager and say, hey, give me the decrypted version of these credentials so I can use them to make a query to Amazon RDS. And so pulls those credentials, makes that query, gets the data it needs, right? And then lastly, we mentioned this concept of provable security, things like lifecycle management of certificates, of keys, of secrets, but also the ability to prove to your auditors, to your internal compliance folks that, hey, we're doing the right things in terms of data protection. We have this data secured, and we can prove it to you. We have logs, we have audit reports generated from the Private CA, for example. And so we're able to kind of show you, here's how the data is being used, here's how the keys and certificates that protect the data is being used. And so there's a lot of services here. I'm not going to go into all of it, but a couple of things I'll call out is, Ritesh mentioned AWS Config can be used to see, hey, this secret has not been used in the past X amount of days. Maybe this secret is not protected with a customer managed key. That's another managed rule. So maybe internally you have requirements to say, I only want my data to be protected by customer managed keys that I control the access policy for, and I have kind of more control over how this key is used. So you can use those managed rules in config to say, alert me or tell me when, my secrets are not protected by a customer managed key, for example. You also see on the right-hand side that Lambda rotation, AWS Lambda rotation function, which can be used to rotate those secrets. And like Ritesh mentioned, we've had some pretty significant releases in the past year or so where you're able to really have a lot more control over when that secret is rotated, and how frequently it's rotated. So you have this concept of rotation windows and shorter secret rotation, where you can say, I only want this secret to be rotated during my usual maintenance window, maybe Wednesday night at 11 p.m. or something like that, right? And similarly, maybe this is highly sensitive data, so you want that secret rotated very consistently, and you might have it rotated every 4 hours to ensure that you have the smallest impact radius should that secret be somehow compromised. And again, of course, as we've mentioned a few times now, these services are all integrated with AWS CloudTrail, Amazon CloudWatch, so you can see those events when the keys are accessed, when the certificates are renewed, when secrets are rotated. If that rotation fails, then you need to take some action potentially to do that. So that kind of covers the sample workload. Again, nothing too fancy here. It's a very simple application, but I just wanted to showcase how you can kind of put these services together to complement each other. and I'll pass to Ritesh to wrap things up.
All right, so wrapping up, I know it's been a long one. So what I'll say is there are maybe 4 takeaways, but you see 3 here. One of the key ones that we don't mention is obviously because it's always there. Every service in AWS is a managed service. So it aims to eliminate some of the heavy lifting that you as customers have to do. So that was probably the theme of majority of the presentation. But then the other 3 takeaways that I would say you would want to take from this is we are constantly and consistently wanting to innovate for our customers, hearing back from our customers. One of the ones that, or the couple that are listed here, the AWS Payment Cryptography. Clear need out with customers, clear blocker for them to migrate to AWS, which they intend to do, but cannot do because of this, if you will, legacy setup. So that's where AWS Payment Cryptography will help and is helping. The Database Encryption SDK is an exciting launch. I think there are customers that want to do things by themselves. There's an opportunity to use SDK that is approved and set up by our cryptography team, our crypto tools team, that you can leverage in the coming months, sure. Obviously, there is a theme, and as you can hear, the intent is always to figure out a way that customers can optimize the costs, but not lower their security bar. Right? The Private CA Connector for Active Directory clearly eliminates some of the PKI upfront costs for you. And the biggest one, the S3 bucket keys, right? As Zach said, close to 99% reduction in cost, which is great. I mentioned it at the top of the slides, top of the presentation. The last one, we aim to eliminate human from decision making in security. That's kind of the North Star, if you will. But the intent is to minimize as much human decision making. And a couple of things that I would say you want to take out of this is the ability to manage rotations for your secrets. Once you have a secret in there, you set it up for rotation, it just happens. You don't have to take any action outside of setting it up for provable security through config. What you can even eliminate from is not have developers or builders, as we call them in AWS, actually type in the password. So you can ask AWS services to generate passwords for you at whatever strength and whatever configurations that you need, and they'll get generated and rotated right away. So I would say those 3, if you can take away anything from an hour of discussion, and thank you for accompanying us through this journey of data through AWS. Hopefully that helps you securely move your workloads to AWS. And last but not the least, I'm going to plead, but please complete the session survey. If you can, opportunity for us to get some feedback, both of us, and maybe adapt our presentations for the future. So thank you, stay safe and stay secure. Thanks.